Hello, everybody. Welcome back, YouTube. Welcome back to Learn with Earthquake Dude. This is lesson 3, measuring earthquake shaking. As always, please remember to follow me on TikTok, Twitter, Instagram, earthquake_dude. I am your professor for today, Professor Brian. And yeah, let's get into a very awesome topic of measuring earthquake shaking. We're going to start off with this quote from Congressman Samuel L. Mitchell. I almost said Samuel L. Jackson, low-key. Describing the New Madrid earthquake in December of 1811. The first earthquake was felt about a quarter of an hour after 2 in the morning of the 16th. It roused persons from their sleep by the clatter of windows, doors, and furniture in tremulous motion. There was a rumbling, distant noise resembling a number of carriages passing over a pavement. In a few seconds, the motions and noises had considerably increased. At 47 minutes after 2, a second shock was felt. At 34 minutes after 3, a third came, which was as tremulous as the first, but not followed by so much noise. A little after daylight, there was a fourth. At 8, a fifth. And at 11:30, a sixth. Several persons felt or imagined others. There were of different lengths, from 2 minutes to a few seconds. No lives were lost, some chimneys were thrown down, and a few stone houses. So a very, very detailed description of the shaking of the 1811 New Madrid earthquake. So to begin, I'm going to show you this cool simulation of an earthquake starting on the southern section of the San Andreas Fault and how it propagates throughout the land. Okay. So after about 30 seconds, you can see the rupture is spreading and traveling very, very quickly. You see there, those are your seismic waves right there. That you see after a minute, I hit Los Angeles, San Diego, about to reach Santa Barbara and Bakersfield after almost a minute and 5 seconds. So just a little cool simulation of how these waves travel, right? Now, intensity is felt very differently depending on where you're at, depending on the magnitude and how close you are to the epicenter of the earthquake. So there's various ways of measuring the strength of an earthquake and shaking at a particular motion. So we can use a thing called a seismograph, which we'll talk more about in the next lesson. And that gives an objective measurement of intensity at that location that the seismograph is located at. But before the invention of the seismograph, subjective descriptions were used to define the intensity of an earthquake at a specific location. And that's what we're going to be focusing on today, is this subjective description and how we dive into this scale called the modified Mercalli scale. So earthquake intensity scales, various intensity scales were designed to semi-quantify the strength of the earthquake shaking at any given location by assigning a numerical value to a various verbal descriptions of the shaking and its result. So that scale is called the modified Mercalli scale, and it's this one right here in red. And it's the most commonly used intensity scale in the United States. Now there is another one called the Rossi-Forel, which is mostly used in Europe. We don't use that one here. We use the modified. Okay, so let me show you the scale. There it is. This is the modified Mercalli, and it's an intensity scale that runs from 1 through 12. That's the intensity. Then the shaking description for each one associated. We start out from not felt to weak to light to moderate, strong, very strong, severe, and the last 3 are extreme. And then you have your descriptions or damage for that earthquake. So I'm going to show you multiple examples here, but you can see an intensity 1 means nobody felt the earth. Very, very tiny, and not felt except by a few very few under especially favorable conditions, meaning you're very, very close to the epicenter, and that's the only way you would have felt it. Now, for example, an extreme 10 would be some well-built wooden structures destroyed. Most masonry and frame structures is destroyed with the foundations, rails are bent. So that's a very, very intense, big earthquake. Okay, so let me show you some examples here. So a modified Mercalli intensity 5 here. Felt by nearly everyone, many awakened. Some dishes, windows were broken, cracked plaster in a few places, unstable objects overturned, disturbances of trees, poles, and other tall objects sometimes noticed. Pendulum clocks might stop. So this is after the 1994 Northridge earthquake. This particular location described the effects of the shaking and deemed a intensity 5. Here's another 5. Felt by nearly everyone, many awakened, some dishes, windows, etc. broken. And it's the same description that we see um, in the modified Mercalli scale. This one was an intensity 7, so everybody runs outdoors, which is not what you're supposed to do, by the way. Damage negligible in buildings of good design and construction. Damage slight to moderate in ordinary well-built structures. Damage considerably in poorly built or badly designed structures. Some chimneys broken, and people driving cars definitely felt the earthquake. So again, here's another earthquake from the 1994. This is another example of the 1994 Northridge earthquake. You can see the chimney clearly collapsed. This is an intensity 8, so now we're getting to much stronger intensities here. So damage slight in specially designed structures, panel walls thrown out of frame structures, fall of chimneys, factory stacks, columns, monuments, walls, frame houses moved off of foundations, if not bolted. That's insane already. Heavy furniture overturned. Persons driving in cars are definitely disturbed by it. Absolutely. And now we're getting to really intense stuff. You can see the whole foundation has shifted from this house because it was not properly bolted to its foundation. So that's pretty incredible, and that's strong. That's, yeah, we're getting to some crazy stuff here. I believe this is the 1994 Northridge earthquake as well, but we're getting closer to the epicenter, which is why the intensities are also climbing up. Here's an intensity 9. Damage considerably even in specially designed structures. Well-designed frame structures thrown out of plumb. Damage great in substantial buildings with partial collapse. So an intensity 9, you're getting partial collapse building. This is also a photo from the 1994 Northridge earthquake on a Kaiser Permanente building. Yeah, it's getting really devastating at this point. Here's an intensity 10. Some well-built wooden structures destroyed. Most masonry and frame structure destroyed with foundation. So you're looking at buildings collapsing and within each other, and it is getting really catastrophic. And I think we have one more for a intensity 11 here. Few, if any, masonry structures remain standing. Bridges destroyed, broad fissures in the ground, underground pipelines completely out of service, earth slumps and landslips in soft grounds, rails bent greatly. So now we're getting to the point where buildings are not even surviving at this point. They're just completely collapsing with each other. I think, I'm not quite sure where this photo comes from. I think it's 1994, but I'll have to double check that. But it's just an example of buildings completely collapsing in an intensity, right? So this is just using descriptions of what the earthquake is doing, shaking wise, intensity wise, to create this modified Mercalli scale. So it's a useful way to collect data without having seismometer. So here's a modified Mercalli intensity map of the 1994 Northridge earthquake. Notice closest to the epicenter, you have more of that red color, so they experience violent to extreme shaking. As you start moving away, you got the strong and very strong, and the further away you are from the epicenter, you have, light to moderate shaking. So, but the only problem with the modified Mercalli scale is that there is no single number that describes the intensity of shaking in an earthquake, meaning when you talk about magnitude of an earthquake, you're not really getting that from the modified Mercalli scale. You're just getting descriptive details of the shaking depending on its location, right? Again, it also depends on the location, so how far from the epicenter you are, and it depends on the local soil conditions, right? You're more likely to feel much more intense shaking near the beach than you are on top of a mountain. And it's best displayed on a map. So collecting all this data and creating a map can show you the big picture on the intensity of shaking based on the location of the epicenter and how far away you are from. But again, this is giving you a lot of useful data, but there is no single number, right? We all know that the magnitude for this magnitude 7, but just by looking at this map and collecting the data from people's experiences of that earthquake, we can't really get that numerical value per se of the magnitude. So why is this important? It is very important. So as a citizen who experiences earthquakes, and if you ever feel an earthquake, It's very, very important that you go on the Did You Feel It website, which is right there, linked right there, earthquake.usgs, and you fill out the survey. Tell us if you felt it. Describe it to the best of your ability. And even if you didn't feel it, that's still important data. If you were in, let's say, Ridgecrest, and there was an earthquake in the Inland Empire, right? You still want to say, yeah, I didn't feel the earthquake. I saw that there was one, but it's still really important data to collect. So even if you didn't feel it, still go ahead and write that stuff out and fill out the survey, because it's really, really important. And then the program will figure out the intensity of shaking you felt and will add your data to them, which is what this looks like here. So really, really important that you have to fill that out after the next after you feel an earthquake. So the only limitations with the modified Mercalli system is that, one, it's super subjective, which means people are going to have different experiences and they're going to describe their experience much, much differently, even though they might be near the same place. And it just becomes subjective. Right? People just are going to describe things differently. And the other problem is that there's no data where people don't live. So in the places, in the more rural places, like in the desert, the mountainous areas, there might not be people living there who can accurately fill out that survey. So here's an example of what that looks like. This is an earthquake in Parkfield, California. Notice there's a lot of gray spots. Those gray spots are no data. So nobody there went on the website and completed that survey to describe their experience with that. So it has limitations, but it's still very, very useful. So next time you're in an earthquake, make sure you fill out the survey and help contribute to the data collection. So I'm going a little too much on this video, so I'm gonna end there for lesson 3. As always, I hope you enjoyed it. I hope you learned something. Please leave any questions in the comments below, and as always, please like, drop a comment, and subscribe if you haven't already. Lesson 4 will be dropping in a couple days. We're going to be continuing. This is a whole series where I give you guys a free earthquake class here on YouTube. Thank you again so much for watching. Enjoy the rest of your day, and I'll see you guys in the next.